Hey guys! So today you and I are going to talk about refactors. So let's get into it. So the question in question was, hi Frederick, what are your most successful micro refactoring techniques that you use in order to improve code without any major rewrites? Oh, this is a good one. The reason why it's a good one was because I was a little bit, I'm gonna be honest, I was a little bit sad. I felt sadness in my heart the other day. I was talking to a team that had asked to get some suggestions on how they could improve their code. And the product manager, she had asked me basically to take a look, right? And so I gave them a few suggestions on what I think would work using the thing we're going to talk about, like how I usually approach these things. And she was a little bit like, oh yeah, okay, like we're going to have to take this hit and so forth and so forth. And I just, in my heart of hearts, I realized that this woman will never understand how many years and how much practice it has taken me to get to a point where my answer to her query to basically fix her whole system is not rewrite the whole thing, because her developers have the big rewrite in mind, and I know that the average software developer would also consider it to be like a big rewrite thing, and I'm pretty sure we can do it without the big rewrite. I'm going to tell you how, but it was so sad. It felt like it's I imagine how a waiter, or every waiter who's ever come up to me when I've been in a restaurant and wanted to tell me what I'm about to eat. That's about as disappointed I felt, because I could not care less. I could not care less. Like, just go away, I'm here to eat. I don't want to know what it is. I don't want to know what cheese this is or where it came from, anything like that. It will sustain me. It will taste good. That is all I need to know. And so the way that I do it, at the very least, when it comes to micro refactors and so forth, is that the first thing that I suggest to you that you do is to take a look at your layered model. That's the first thing. So one of the most fundamental mistakes that can happen is that you leak logic, or like various, like you don't follow good practice when it comes to I'm not sure if you're familiar with the layer model, but usually you have various layers where you have like a data access layer, you have some type of business logic layer, and you have some type of controller, depending on if you're front end or back end. But anywho, usually there are these natural areas of responsibility that you will find both in terms of what files do, or components or function and stuff like that, but you have bigger entities as well. Now, one of my favorite things to do in a micro refactor is to take a look at all my business logic and see, all right, have I successfully decoupled my data fetching from my business logic? And this works both in front end and in back end. So for example, one of the front end developers' biggest sin is to use network calls all across in every single component, right? So basically you have, like, if you're using, in my case might be React or something like that, you use fetch in components or things like that. One of the first things I tell them is the same thing I tell the backend developers. Don't just do arbitrary network calls and database accesses and stuff like that. Create an API client or a database client, like some type of wrapper, a DAO for those, or like a repo, depending on what backend type of deal you're doing, right? The reason why I'm saying that is because what you want is to, like, I've always found that to be very useful at the very least, try to centralize the data fetching into an abstraction, so that just getting the data is the same thing every single time. You just call a function. You don't have to copy paste the URLs over and over, have them in some weird constant somewhere. Just create a function that gets you, like, it gets you the data that you're looking for, right? And that way you get a little bit of reusability. But that's the first thing. Now you have removed the unnecessary boilerplate that might go into every time you want to fetch some data, and of course then you're going to figure out very quickly that you have a bunch of transformations going on, like where you now have to start to think about your data models, because the data model, I argue, is the first and most important thing to get right if you want the system to be clean and easy. And the reason why this becomes very powerful for you now is because once you try to do this, you're going to see that, right, your business logic might mutate this data in various ways, and might change it in some way, or so forth and so forth. And now you come to the next layer, which is, okay, so now you might have a data accessing layer that gets you the data, and then you have a bunch of transforms that wants to take your data and put it into a different shape. That becomes another nice abstraction that you can make, where you know that, for example, a classic one is, which is, again, worst thing that you can do, if you ask me at the very least, which is that you have your raw data model. And it doesn't matter if it's front-end or back-end here again. Like, the front-end developers are getting the data from an API, back-end developers are doing the same thing. It's just that they're getting the raw data model from the database, right? And then you start passing that around in the whole code base. And whatever you need to do something with the data, you just ad hoc transform it into the shape that you want it to be. My argument is, don't do that. Add another layer on top of the actual data fetching that just transforms it into the model that you want, because you don't have to have the model that is in the database to be the only way you access that data. You can convert it to a model that is shaped into the shape that you want it. So what I will do is, for example, I will create an interface or something like that that might be a subpart of the data. It's not all of it, it's just the fields that I need or something like that, and then I use a class or I use a function or something like that to take the raw data that I'm getting from the API or from the database, and I map it into the shape that I need for whatever I'm supposed to be doing, because I never want to work with more data than I can and than I have to. That way I reduce the loose coupling, all of these sort of things. Right? These are the basics. Now, once I've done these things, now I know that the only thing I have left to deal with is the actual pure business logic, because these things are like low-hanging fruit things that will clean up quite a lot. Now comes the really tricky part, and that is to figure out, okay, so how can I get the source code? Because that's usually the problem where, like I face, like in my little story here with the developers that I'm working with, their problem is basically that the source code is like all over the place. The business logic makes no sense anymore. And then so I'm a big fan of modular monoliths when it comes to structuring repositories and so forth. So the thing that I try to do is to teach or to tell my developers, or like whenever I have the chance, if I'm the tech lead or something like that, that what I want us to do is to just in the root of the project create a source folder. In that source folder we will have one folder called shared, and then we're going to have a bunch of entry point systems or entry point modules basically. And the idea here is that every folder here has a README file describing what that model does or that module does, and it should only expose something like, if it's a backend system, a controller. In other words, it exports a controller. And if it's a front-end application thing, it's just exporting like a page or a component or whatever we're doing, right? It's just a list of different like isolated components, because what I'm trying to achieve is in essence encapsulation, but at the folder level. The shared folder has the same structure. The only rule for that one is that you only put stuff there that is dependent between, like code that has more than one dependency in the main source folder, right? Now here comes the tricky part. When you want to start moving these things, you're going to have to think about, okay, so if you want to transition from, say, legacy code or a way that the system is working where you don't want that into something else, I argue that it's easier to create a simpler function or a smaller or more simplified abstraction based on your needs than to fix the existing code. And so how do you do that? Well, I'm glad you asked. That's when usage of interfaces and good abstractions is like the best thing ever. So what I try to say is that instead of just rewriting the whole system, find the point where, let's say, you're calling a method or a function or something like that does something very complicated, and you want to refactor that thing, and you have no way of doing it in just one sitting. That's not a problem. All you have to do is to create a interface on top that just has a contract to whoever's calling that function, because now you don't have to fix the whole system. Now you've decoupled the calling side from the actual implementation, and then underneath you simply replace the code. So you have two parallel versions. You have the old version, which is the thing that is ugly that you want to refactor, and you have your new clean version that you are trying to put into the shape that you wanted. And the only thing that that new thing has to know is that the current parameter, you can't change the parameters perhaps or so forth. You might need to maintain the arguments or something like that if it's like a function or a method or something like that. That's okay. Remember my mapping rule. Because the new abstraction that you're creating, it doesn't have to follow the same rules as the old one. All it has to do is to maintain the same interface. Then you can take those arguments, convert them into a nice clean data shape that you can work with, and then you can start recreating like your logic. That way you don't have to, like, then you can do an A/B thing, right? You can try out your new function that does something nice and fancy without removing the old thing. That's one thing that you should really learn quickly, guys. Whenever you're refactoring, whenever you're doing stuff, don't remove the old stuff. Make sure that you do the parallel type of thing, right? Get the new thing, create it, and make sure that it works before you delete the old thing. And that's why using a good, like a function or like an interface or something like that is so powerful, because that means that you can decouple the entire code base. You can call that function, you can have 100 call signs for that function. It does not matter, because you don't have to refactor all that good stuff and like change it or so forth and so forth. All you have to do is to change it to be an interface or a function or something like that. Then go to that function and internally, as I said, scoop it out from the inside. You are like fixing it from the inside, so without changing the interface. If you follow these rules, I find that, at least in my world, like then it's like Boy Scouting, just making sure that you do that every single time you're touching some code. That's the hard part. Honestly, that is the hard part, to get to people to commit to it over time. Most people don't want to work that way. I prefer it work that way. That's how I do it at the very least. But if you follow these principles, to this day, I have never needed the big rewrite more than for things where this is like completely impossible. Let's say that you were to, I don't know, change the build system or something like that. But well, at least in terms of source code, this should work for practically every use case, at least the ones that I can think about. So what I want you to take away from this is that my tips for micro refactorings that avoid the big rewrite is: number one, make sure that you have a good separation between your business logic and all the other parts. So try to move all the data fetching to a dedicated DAO or repo or something like that, and then create a transformation layer so that the business logic, like instead of just passing around the raw model that's in the database or is coming from an API, make sure that you create a nice, like a class or like an interface or something that just gives you the data that you need. That way your business logic doesn't have to, like, you're scooping away a bunch of extra stuff that that is leaking into the application logic by just creating this kind of dumb, honestly, it's the dumbest thing in the world. Like, it's just getting the data and giving it to you, and then you just have to know what the business logic needs from that data and convert it into that shape, so you don't have to reproduce that all over the place, right? That said, with that, you're left with basically pure business logic. Now, that part, I argue, should be put into modules. Like, you split them on domains. Usually that's what I do, like user, products, orders, etc., etc. I put them in a basic, like, unless I have like a distributed repo or something like that, I usually put it in the source folder, and then I try to achieve encapsulation, just as we do with object-oriented programming, but I try to do that at the folder level. That way I can isolate and segment things into nice and clean modules. I have a shared model, so that code that needs to be shared between more than one of these things has somewhere to go. That way I can control my dependency graph, so it's pretty flat. Like, everything is, the top node is the shared folder, and everything underneath is just one of the controller endpoints or components that it's going to use, right? If it's not necessary to share it outside of the folder, then it just exists within that folder, right? It basically becomes its, like, the way I think about it is that every single folder there should be its own NuGet package, the Maven package, or NPM package or so. It's something that should be possible to just lift out of there and make into its own new repository, or put it on like one of the registers, right, and shared as a library, right? If you think in those terms, it's pretty easy to keep it scalable. And the way that you can start moving things like that is to figure out, okay, so where is that code being used, and who is depending on it? because the other code that is depending on whatever you're trying to move. Remember, if you use an interface or a good abstraction, you don't really have to change all the code that is dependent on the stuff that you want to refactor, because as long as you keep the contract, you can change the abstraction from inside, and that is more powerful than trying to just rewrite the whole system in one go. Just maintain the old stuff that has its way of working right now, and pick something, ideally something that is easy to refactor, and just change it from without changing the interface. And then when you feel like it works, remember, start with the new stuff, add that in, make sure that it works, then you can replace it. That's how I do it. Have a great day.